This is a video about some mathematical intuition that you can inject when you are solving for the Charles's law, Gay-Lussac's law, and also Avogadro's law. Now, please take note that all of those that I've mentioned are having a relationship that we call directly proportional, direct proportionality. So if you have, for example, Charles's law is formulated like this: V1 over T1 is equal to V2 over T2. Essentially, you are saying that the volume here and the temperature have what we call are what we call have are quantities that have direct proportionality. So they are directly proportional to each other, right? So that means that essentially when V goes up, temperature goes up, and when V goes down, temperature also goes down. So they kind of go together. And again, the intuition here is to say that, say for example, my volume is kind of like 30 liters, and then my temperature is 600 Kelvin. And then now my volume from 30 liters changed to 15 liters or maybe 10 liters. And then I don't know the temperature. So now you can invoke what you know, which is they are directly proportional. So whatever happens to volume is also what happens to the temperature. So here you just have to reason out that, hey, if I look at it, the volume kind of decreased, right? And it decreased by kind of multiplying it by 1/3, right? So 30 times 1/3 is 10. Or you can say it's divided by 3, right? Maybe that's easier, that this was divided by 3. And since you know that volume and temperature go together, they have a direct proportionality between them, that means that also is the same thing that happens to the temperature. So that your 600 Kelvin will be also divided by 3 to give you the answer. And obviously that answer will be what? 200 Kelvin, right? So see, you do not even have to kind of use the formula to solve for it. Just kind of mathematical intuition, understanding what direct proportionality means. It means if you multiply this by 3, the other gets multiplied by 3. If you divide this by 2, the other also gets divided by 2. They go hand in hand. When this goes up, this goes up. This goes down, this goes down. If this goes up by 10 times, this goes up by 10 times. If this goes down by 1/3, this goes down also by 1/3. So that is what is meant by direct proportionality. And again, that's just Charles' law. You can also apply that to the other laws, like for example, Gay-Lussac's law, which is still kind of the same thing, but it's now looking at your temperature and your pressure. So you just say here that P and T are directly proportional to each other. And again, what that means is when P goes up, T also goes up. And when P goes down, T also goes down. And again, you can say things like, if its pressure, original pressure was say 4 atm, and then the temperature was around 1000 Kelvin, and then now we cool down the temperature to say 500 Kelvin or maybe 100 Kelvin. What would happen to our temperature? Well, again, you reason out that it is direct proportionality. So how did you get from here to here? You kind of divide it by 10, right? 1000 divided by 10 is 100. So therefore, because of the direct proportionality, they go together. If this gets divided by 10, this also gets divided by 10. So now you know that your pressure would drop down to 4 atm. Okay? That's for Gay-Lussac's law. Again, the same thing for Avogadro's law, which you just have this, which is, sorry, you just have volume of the state of the gas, initial state of the gas, divided by the number of particles is equal to the second state of the gas, volume, divided by the number of particles. And again, you say that V and N, another way to write this is directly proportional to each other. So therefore, again, when V goes up, N goes up. When V goes down, N goes down. And again, they go up and down by the same factor or the same scale. So that if you have, let's say, that 4 meter cube, and then you have here, let's say, 6 moles, right? And then what happens is your moles change to, let's say, 8 moles. And then you are going to predict, or you're going to solve for how much is will be volume 2. And again, all you need to do is kind of think about, okay, how did I get from here to here? What do I multiply to 6 so that it becomes 8? Okay, what do I multiply to 6 so that it becomes 8? So what would that be? And that will be the same factor that will go in here, because remember, they have this direct proportionality. So if this goes up, the other also goes up, and if this goes down, the other also goes down. So therefore, and they do that in the same factor. So here, you would probably, if you imagine it, if you think about it harder, you would probably imagine that this is multiplied by 4 over 3, right? 4 over 3, 6 times 4 is 24, divided by 3 is 8. So it's multiplied by 3. So guess what? Direct proportionality. So therefore, the other value must also be multiplied by 4 over 3. So that gives you 16 over 3. So this would be 16 over 3. I don't want to divide this so that we don't have decimal numbers, but that would be 16 over 3 meter cube. Okay, that's the idea. You could also divide this and leave it in decimal form, but the idea here is this: whatever happens to the number of particles also is the same thing that happens to the number of moles, to the volume, because again, they have direct proportionality. And again, that applies to the three: Gay-Lussac's law, Charles's law, and Avogadro's law, because all of them, the three of them, have what we call the quantities that are involved in each of those gases have a direct proportionality with each other. In Charles's law, it's volume and temperature. In Gay-Lussac's law, it's pressure and temperature. In Avogadro's law, it's volume and number of particles.